In this video, I'm going to talk a little bit about what scientific notation means. Let's say I have a number that is 2.4 times 10 to the fourth power. Right? We write it in this form so we don't have a long number with a lot of zeros. But if we want to write it with zeros, we call that standard notation. So to change my number, I'm going to write it under, this is 10 to the fourth. Since this is a positive number, my decimal place moves over 4 times. In each one of those bumps, I'm going to add in a 0. So 2.4 times 10 to the fourth equals 24,000. If we look at a bigger number, so let's say we have 7.5 times 10 to the eighth. Same thing, I'm going to write my number underneath. Since it has an 8, I move my decimal place over 8 times. I'm going to add in zeros. So I end up with 750 million. Now this is a number that's really big. If I tried to graph that number on a piece of graph paper, it'd be kind of confusing to figure out how to do that. So when we graph our numbers for this part of the lab, we focus just on these numbers in the front before our times 10 to the eighth or times 10 to the fourth. Right? Now let's say we have 1 to the negative power. So if I have 1.9 times 10 to the negative 2. I'm going to write 1.9 down here. Since this is negative 2, my decimal place moves over 2 to the left. And this would equal 0.019. Now, one that we have that we see sometimes is 2.0 times 10 to the 0th power. Normally, we'd never write anything this way. 10 to the 0th, or anything to the 0th power, equals 1. So this is like 2.0 times 1, or it's just 2.0. So if you have anything to the 0th power, you could always just write the number in the front. In this video, I'm going to talk about how you convert your exponents to graph in the second part of our assessment for the asteroid drop 1. Now, for these values here, they're in scientific notation. Another way to write this notation is 2.8 times 10 to the eighth. Now, all of these numbers have different exponents here, except for these two that happen to be 6. In order to graph, those need to all be the same. If they're not the same, and I was to put 2.8 close to 3.9, these are very different numbers. This is 5 powers of 10 greater than this one. That would be like graphing something 1,000 in the same place as something to the 1,000,000th. Right? They're very different numbers. This one's very big, this one's very small. So I need to make all of these values e to a number the same. I recommend picking a value that's somewhere in between the rest of them. All right? So I'm going to make mine all e to the power of 6. So I want to rewrite my numbers with that in mind. So these ones that are already e to the 6, I can just copy over. Now I have 2 that are smaller than e to the 6. When something is smaller, I move my decimal place to the left. And I move it to the left how many different these are from each other. So 5 is just 1 different from 6, so I move my decimal place to the left 1. And that becomes 0.35 e to the 6. To the third, well, 3 is 3 different than 6, so I move it over 3 times. And I'd end up, zeros go in here, 0.0039 e to the 6. When something's bigger, I move my decimal place the opposite direction. So 7 is 1 bigger than 6, so I move it to 1 to the right. And I get 14 e to the 6. 8 is 2 bigger, so I move it 2 to the right, and I get 280 e to the 6. Now, when I actually end up graphing these, I can eliminate some numbers that are a lot bigger or smaller than the rest. That's not to say these are wrong, they just can make it harder to graph. So this one, e to the third, was much smaller than the others. I can decide to not graph this number. This one, 280, is much larger, so I might decide to not graph those. I would focus on graphing the ones that are left. When I look at converting numbers with negative exponents, I do the same thing. I just need to remember that negative numbers, -2 for example, would be smaller than -1. So given my numbers here, since I have two -1s, and those are kind of in the middle, I'd want to convert all my numbers to be to the -1. So these two that already are that, I can just copy over. Moving up, -2 is 1 less than -1. So I move my decimal point to the left, and this would be 0.56 e to the -1. Now 1 is 2 bigger than e to the 1, so I move my decimal place to the right too, and this is 740 e to the -1. This one, 1.9 e to the 0th, I move it over 1, and this is 19 e to the -1. Same thing as before, this number 740 is much bigger than my other numbers, so I might decide to not graph that number.